guys, this is Mrs. Walker and welcome back to our final lesson of this year. Can you believe it? I remember filming my first one and now here we are and I'm at my last one. And it's been a real adventure. So anyways, this lesson is specifically for the ISS tic-tac-toe lesson for your exit ticket. So if you are watching this but you're not doing that, go ahead and click out now and have a great day, because this isn't going to do you a whole lot of good unless of course you're curious about Kepler. So I'm going to keep it really simple. I'm going to go straight to the questions that are asked in the exit ticket and share a few things with you about Johannes Kepler. And if you guys saw, I was him for our scientific portraits, and so he was the person that I dressed up as with toilet paper around my neck. What kind of life are we living? So anyway, first of all, Johannes, much like many of the scientists that we've looked at this year, was actually a teacher first. He was a mathematics teacher in Germany, and this was during the time of the Enlightenment period. So some of his people who were alive and doing cool things when he was are people like Da Vinci and Galileo as well. So he was alive during a really important time when a lot of advancements were being made. He was first and foremost a mathematician. However, much like a lot of the scientists that we've looked at this year, he had lots of different interests. And one of his that's really interesting and kind of cool is that he was one of the first to create a camera way back in the 1500s, if you can believe it. He created a pinhole camera where he was actually able to start to formulate images based on what he theorized about the eye and how refraction works in the eye, which was confirmed by none other than Leonardo da Vinci, because he was doing a lot of work with anatomy. So I think that that's really interesting how connected these people were, even though they were from all these different places on the globe. Let's talk about Kepler's three laws. Okay, in the first Kepler's law, the most important takeaway is that he determined mathematically that the orbits around the sun of all of the celestial bodies was elliptical. This is important because of the fact that even though people like Copernicus and Galileo had a lot right in their models, they believed in a circular wheels-on-wheels orbit. And what we know from Kepler is that that was actually not the case, that mathematically he theorized it had to be an ellipse for a couple of different reasons. Also interesting is in his second law, he determined that there was a sweep rate. What the sweep rate is it supports the fact that they have to be elliptical orbits, because he calculated a little speed up as they kind of rounded that curve in their orbit. And so what he called that was a sweep rate, and it also gave some credence to the fact that it's not a constant orbit, that there is a slight change, a little speed up as we come around the bend. So that's his second one. And then in the third law of motion, he's making a mathematical claim about the diameter of the planets and of course how long they take to orbit the sun. What's interesting about the third law is that it's specifically what Newton studied when he began to theorize the law of universal gravitation specifically. So it wasn't the apple that inspired all of that from Newton. It really was his musings, his thinkings for a greater period of time on what was being said 250 years or so prior by Kepler. And so he was actually studying Kepler's work when he started to formulate that theory, which is interesting as well. Well, how does all this relate to the International Space Station? Well, simply, sorry, there's a message. Simply, the elliptical orbit is what the ISS uses. Also, the fact that it has an elliptical orbit does mean that it's going to speed up and slow down in certain areas as it's moving around our planet. Other things that are important in regards to things like future space travel and Kepler's laws specifically have to do here with Florida, in that we have a lot of launches from Cape Canaveral and from basically the spaceport area of our state over by Merritt Island on the coastal side close to Kennedy Space Center. And what they have to do when they're sending these rockets out is they have to actually calculate the spin of the Earth and how that rocket is going to move up and then out over the water based on our spin. And much of that is determined by Kepler's third law. So I know that this was really quick. I hope that you found it informative. Kepler is a cool dude. I've enjoyed learning about him several different times in my studies, and I hope you all are well. Go wash your hands, and I would love to say I'll see you in the next one, but instead I'm going to say I'll see you the next time that I see you guys, which of course I hope is sooner than later. Love you. Bye-bye.